G'day ladies and gentlemen, and welcome to Pythagoras 1. In any right angled triangle, the square of the longest side, that's what we call the hypotenuse, this one here, is equal to the sum of the squares of the smaller sides. Now then, what this means for us, if we're looking at any right angled triangle, Pythagoras was a famous Greek mathematician from many years ago. He discovered that if we've got a right angled triangle, this is the smallest side, we'll call it A. The middle side we'll call B, and the longest side, the hypotenuse, we'll call C. The hypotenuse is always the side opposite to the right angle. Now, Pythagoras discovered that every right angled triangle holds true to this formula. A squared plus B squared equals C squared. And this is a really important formula when we get to a lot of mathematics. So I'm going to highlight that in red just to say, guys, learn this formula. Now then, we've got a very nice visualization of two smaller squares in this triangle here. We've extended the sides out, we've made them into a square, we've filled them with water, and watch what happens when we turn the wheel around. The water from the two smaller squares flows into the larger square, and as you'll see, fits in there nice and neatly, very exact. And when we turn the wheel round the original way again, the water from the large square flows into the two squares, showing that as we add those two smaller squares up, we make the larger square. That's a very nice visualization and can help us a lot. If you can remember that, that would be really good for this topic. Now then, how this works with the actual numbers. Let's say we've got a right angled triangle with the shortest side being 5 centimeters, the middle side being 11 centimeters, and we want to find the longest side, the hypotenuse. We're going to call that x. Now then, whenever I'm using a formula, I always write that formula first because it's really helpful. A squared plus B squared equals C squared. It's really helpful to write that formula because when we're substituting in, instead of A, we've got 5, and directly underneath that A, we can write 5. Now we've got to remember the square each time with Pythagoras. Plus, instead of B, we've got 11, so I'm going to write 11 squared equals, and instead of C, we've got x, so I'm going to write x squared. Now then, because we've got wonderful calculators nowadays, I can perform a very special operation here. I can switch over both sides of this formula here because they're either sides of an equals. We want to find x. Now the best way to do this is by square rooting the x squared. Now if I square root the left hand side of an equation, I have to square root the right hand side of an equation. So I've got my 5 squared plus 11 squared, then I've square rooted. There we go, and with the calculators we've got nowadays, guys, if you put that straight in, I've got a Casio FX85, that comes to the square root of 146. 5 squared being 25, 11 squared being 131, add them together, 146. Now then, we can leave the square root on if it makes a number easier to type, but in most questions, they'll ask you to round the decimal off. Now, we're going to round this one off to 3 significant figures. Whenever I'm rounding off, I draw a squiggly equals, and I'm going to take the first 3 non-zero figures. We've got 12.08 on my calculator. I'm going to round that up to 12.1, and the units are centimetres because that's what we're measuring the other sides in, and that's to 3 significant figures. Okay, ladies and gentlemen, thank you. Enjoy your day.